Welcome, geometry students, to a Regents review video for the Geometry Common Core Regents exam. These will be the solutions to the June 2016 Geometry Common Core Regents exam for New York State. So this video is going to feature part 1, which is the multiple choice questions 1 through 12 of the June 2016 Geometry Common Core Regents exam. Just a quick note before we begin. If you are here to copy my answers for any unknown reason and you didn't do the work yourself, please refrain from using this video because the geometry Regents is very difficult. So, if you are here to check your answers or in need of guidance, you came to the right place. Please hit that subscribe button and visit www.nysmathregentsprep.com for a lot more math content. Without further ado, let's begin this exam. I will tell you that I remember this when it was administered and it was quite challenging. So, here we go. All right, question 1 says, a student has a rectangular postcard that he folds in half lengthwise. Next, he rotates it continuously about the folded edge. Which three-dimensional object is generated by this rotation? So, just a few things to remember and jog your memory. A rectangle, in this case, is known as your cross-section. And remember what a cross-section is. A cross-section is where you take a three-dimensional object and you slice it up or down, left or right, or on a diagonal, and it creates a two-dimensional figure. So if we're thinking about, well, which 3D object, if I were to rotate a rectangle around, what would that create? Well, a couple things that you have to know. If it's being rotated, it has to create a circular base. I don't care how square or pointy the two-dimensional figure is, it has to be generating a circle as its base. So we could get rid of choices 2 and 4 immediately because that's not being rotated. So now it's down to choices 1 or 3. The only one that would work is going to be choice 3. That will create a cylinder if the rectangle is rotated continuously about its folded edge. Now, a common example that is used in everyday life would be a revolving door. Because when you go to an airport or you go to a department store, when you go in those revolving doors, you are inside of a giant cylinder pushing against a rectangle. So that's why it is going to be choice 3. And it's pretty simple so far. Okay, number 2, a 3-inch line segment is dilated by a scale factor of 6 and centered at its midpoint. What is the length of its image? Okay, one thing that trips people up is this, centered at its midpoint. That doesn't mean a darn thing, because a dilation, and this is just a fact that you need to know, a dilation always multiplies lengths by the scale factor, regardless. So regardless of where the center is located. So it doesn't matter if it's located at its midpoint, it is still the length of the segment, which is 3 dilated by 6. So it's 3 times 6, that's going to be 18. The answer is choice 4. All right, moving on to question 3. Kevin's work for deriving the equation of a circle is shown below. In which step did he make an error in his work? All right, let's go through each step slowly. So in step 1, it looks like that Kevin distributed the -1 into this binomial. So did Kevin make a mistake here? No, he didn't, because all of the signs are correct. So that's good. Step 2 shows that he decided to add a 4 on the left, but then he subtracted the 4 on the right. Huh? That's his error. Step 2. Step 2 is going to be choice 2. That's the answer, because he broke the golden rule of algebra. What you do to one side of an equation, you must do to the other. This should be positive 4 because, again, according to the golden rule of algebra, what you do to one side of an equation, you must do to the other. So that was kind of a Algebra 1 question, so that should have been fairly simple. All right, moving on to question 4. Which transformation of line OA would result in an image parallel to OA. So we need to know what these things are. A translation is a shift, and it's saying a translation 2 units down. So if we take this line and we move it down 2 units, we get this line right here. Now it's asking for parallelism, okay? Does that look parallel? Yes, it does. Now remember, parallel lines never touch. Those will never touch. And you need to know that translations preserve parallelism. That is a property of a translation. Preserves parallelism. Okay? So if you look at the other answers, look at what they're all saying here. A reflection over the x-axis. Okay, so that's right here. That's not parallel, it's intersecting right there. Then it says a reflection over the y-axis. Again, intersecting right here. Can't work. A clockwise rotation of 90 degrees about the origin. Again, that's somewhere in this quadrant. I don't know where it is, but it's somewhere in this quadrant. Again, it's intersecting. They're not going to be parallel. So choice 1 is the only one that would work. All right, number 5. Using the information given below, which set of triangles cannot be proven similar? So we had to remember a couple things about similar triangles. What are the 3 ways to prove triangles similar? Well, the first way is by angle-angle. If 2 angles in a triangle are congruent, they are similar to each other. Then we have side angle side and side side side, and these two have to be in proportion, meaning that the ratios of the segments are equal to each other. So let's take it one step at a time here. Let's take a look at choice 1. So this looks, just by looking at it, it looks like side angle side. But let's make sure that these sides are in proportion. Is 9 over 12 in proportion to 3/4? Yes, it is, because 9 over 12 is equal to 3/4. So that actually works, and this is side angle side similarity. So this is wrong, because we're looking for the one that's not proven similar. Choice 2, okay? This shows 2 pairs of congruent angles. So this is angle-angle similarity. Those 2 triangles are similar, so choice 2 is actually true. Let's go on to choice 3. Okay, this is angle side side. Angle side side. So that is not similar. Also, even if you didn't know that angle side side is not a similarity theorem to prove triangles similar, look at the lengths of the sides. 2 over 8 is not equal to 16 over 32. 2 over 8 is 1/4. 16 over 32 is a half. Those 2 fractions are not equal to each other. Now, I want to talk about choice 4 for a second. Choice 4 is not showing similarity, it's showing congruency. Now, this is a fact that you just have to know. Congruent figures are also similar to each other. Congruent figures are similar because think about it. If a figure is congruent to itself, all of the angle measurements are congruent to each other, and that's similar by angle-angle. So, congruent figures are also similar. So that is actually true. That's why it's not the answer. All right, so the answer for number 5 is going to be choice 3. Okay, number 6. A company has created an object from a wooden cube with an edge length of 8.5. A right circular cone with a diameter of 8 and an altitude of 8 will be cut out of the cube. Which expression represents the volume of the remaining wood? So basically what we're doing here is we are taking a cube, okay? We are taking a cube. I'm going to sketch a cube here real quick. All right, we're taking the cube, and we are subtracting away the volume of the cone, okay? That's what it's asking you. Can you take the volume of a whole block and then subtract the volume of the cone to get the remaining volume of the wood? Well, what is the volume formula of a cube? Well, that's just length times width times height. The volume of a cone, that's given on your reference sheet, that's 1/3 pi r squared times the height. Okay, now it says here that the wooden cube has an edge length of 8.5. So therefore, this is 8.5, this is 8.5, and this is 8.5. So what we could do is the volume of the cube is 8.5 times 8.5 times 8.5. Understand that that is also written as 8.5 to raised to the third. Okay, that's 8.5 raised to the third. And we are subtracting the volume of the cone. Well, that's 1/3 pi. Now the radius, well, what's the radius? Well, it tells us that the diameter is 8 of the cone. And it says it has an altitude of 8 as well. So the radius is actually half of 8, which is 4. So that's going to be 4 squared times the height of 8. Great. So your expression is 8.5 to the third minus a third pi times 4 squared times the height of 8. And that answer is going to be choice 4. All right. And that is the answer to number 6. All right. Number 7. This is a good question. Two right triangles must be congruent. Keyword there is must be congruent if what? Okay. So we have two right triangles. How do we know that this triangle is congruent to that triangle? Well, it says here, choice 1, an acute angle in each triangle is congruent. Does that prove congruency? No. That would prove similarity by angle. So this proves triangles similar, not congruent. The lengths of the hypotenuses are equal. That, ladies and gentlemen, was the trick answer to this question. That is not congruent. It could be congruent, but not necessarily. It says must be congruent. You could have different lengths of legs and still yield the result of the hypotenuse, or the same hypotenuse. Choice 3, the corresponding legs are congruent. That's your answer. Because corresponding legs, that's your a squared plus b squared. If your a squared plus b squared is the exact same number, it has to equal c squared. So therefore, these two triangles would be congruent to each other if the corresponding legs are congruent. All right, so the answer for number 7 is going to be choice 3. Number 8, which sequence of transformations will map triangle ABC onto triangle A prime, B prime, C prime? So it looks like that the little triangle is being rotated and then it's being dilated by whatever scale factor it is to get the bigger triangle. So I'm looking for a rotation and a dilation. Not this one, not this one, not this one. It's going to be choice 4. There's a rotation and there's the dilation. That is what's being shown on the graph. All right, number 9. In parallelogram ABCD, diagonals AC and BD intersect at E. Which statement does not prove parallelogram ABCD is a rhombus? Okay, so we're looking for the property of the answer choices that does not prove a rhombus. So what I'm going to do is I'm going to draw myself a picture of a rhombus. A rhombus has 4 congruent sides. So I'm going to label this as ABCD first. A rhombus has 4 congruent sides. Okay, that proves a rhombus. Also, the diagonals of a rhombus are perpendicular to each other. Okay, so these form right angles in the middle. Now, the diagonals also bisect the angles. Okay, so all these angles bisect each other. All right, so no, I'm sorry. The diagonals bisect the angles at its vertices. So we're looking for the one that does not prove a rhombus. Okay. Choice 1 says that AC is congruent to DB. That's showing the diagonals. Are the diagonals congruent in a rhombus? No. Diagonals are not congruent in a rhombus. That's actually the property of a rectangle and a square, but it's not the property of a rhombus. So that would be your answer. Choice 2, this is showing consecutive sides are congruent. Now, if you have consecutive sides that are congruent, that absolutely proves a rhombus, because that means that all of the other sides are congruent to itself. If two sides are next to each other, for example, they're saying that AB is congruent to BC. If these two sides are next to each other and they're congruent, it has to be a rhombus. Choice 3 is saying that the diagonals are perpendicular. Yeah, they're perpendicular. Those diagonals are perpendicular in a rhombus. That proves a rhombus, right? And AC bisects angle DCB, and a rhombus does bisect the vertices. So all of these prove a rhombus. Choice 1 is the one that does not. All right, that is question number 9. Number 10. In the diagram below of circle O, Line OB and line OC are radii, and chords AB, BC, and AC are drawn. Which statement must always be true? Must always be true. So we're looking for angle relationships or triangle relationships. Choice 1 is saying that the measure of angle BAC is congruent to the measure of angle BOC. No. That is not true. Because the measure of angle BAC, this is an inscribed angle. Okay? And an inscribed angle, by definition, is 1/2 the arc it intercepts. In this case, it's intercepting arc BC. So this is an inscribed angle. It's 1/2 the yellow arc. This angle over here is a central angle. And a central angle is equal to the arc it intercepts. So therefore, these two angles cannot be congruent to each other. Now, choice 2 says the measure of angle BAC, which by the way is an inscribed angle, is equal to 1/2 the measure of angle BOC. Is that always true? Yes. By definition, an inscribed angle is equal to 1/2 of the central angle. For example, if this yellow arc, let's just say hypothetically speaking that this was 80 degrees, your central angle would be 80 degrees and your inscribed angle would be 40 degrees. Well, this theorem satisfies. The inscribed angle is 1/2 the central angle. Choice 3 shows that triangle BAC and triangle BOC are isosceles. That doesn't necessarily have to be true. It looks isosceles, yeah, but that doesn't necessarily have to be true because an inscribed angle could have different chord lengths. So that's not necessarily true. And the area of triangle BAC is twice the area of triangle BOC. Again, not necessarily true. Those are both assumptions. So choice 2 is the correct answer. Okay. Number 11, a 20-foot support post leans against a wall, making a 70-degree angle with the ground. To the nearest tenth of a foot, how far up the wall will the support post reach? So your job is to create a figure. Okay. So it says here, I'm actually going to flip this around here. It says a 20-foot support post leans against. Okay. So this right here is a 20-foot support post. And it leans against the wall, so this is the wall. And it makes a 70-degree angle with the ground. How far up the wall will the support post reach? So we're looking for this over here. This is a classic SOHCAHTOA question. Okay? I'm going to draw my little stick figure down below. Ooh, that guy doesn't have any legs. I'm going to draw my stick figure down here. Your 70 is your reference angle. We have our x, which is our opposite side, and the 20 is the hypotenuse because it is across from the right angle. So if we have O and H, we're using sine. So we have the sine of some angle is equal to the opposite side over the adjacent side. So the sine of 70 is equal to the opposite side, which is x, over the adjacent, which is 20. Okay? And now what I'm going to do is I'm going to cross multiply. Put that over 1. I have 20 sine of 70 is equal to x. Now I'm going to plug this into my calculator. By the way, I use the TI Inspire CX calculator. It is one amazing calculator. I suggest to purchase it. You can find the link on my website to purchase it. So I go to my calculator, and I click on trig, and I click on sine of 70, and I'm going to multiply that by the number 20. Your answer is 18.79. So x is approximately equal to 18.79. It says round to the nearest tenth, so that 9 is going to up the score to 8. So that's why number 11 is going to be choice 4. All right? Number 12. Line segment NY has endpoints n, -11.5, and y, 5, -7. What is the equation of the perpendicular bisector of NY? Now, I want to talk about this for a second. This question, it's not hard, it's just tedious. You need to find the perpendicular bisector. So that's a lot. Because the perpendicular bisector is A, perpendicular to the original line, forming right angles, and it's a bisector, means that it passes through its midpoint. So this is what we have to do. There are 4 steps in order to accomplish this task. So here we have step 1. Step 1 is to find the slope of the original line. Okay? Find the slope of the original line. So if we have points n and y, we could calculate the slope using the slope formula, which is the change in y over the change in x. That is going to be, let's see here, negative 7 minus 5 over 5 minus negative 11. Oops, my apologies, that doesn't look that great. 5 minus negative 11. That is going to be negative 12 over positive 16. That's going to be negative 3/4. Okay, so that is the slope of the original line. Step 2 is to find the slope of the perpendicular line. So what we have to do is we have to take negative 3/4 and we take the negative reciprocal of that, we flip the fraction and we change the sign. So that will become 4/3. That is the new slope of our new line. Okay? Now, then it says bisector. Bisector should be written in your head, means midpoint. So step 3. Find the midpoint. So the midpoint formula is equal to the average of the x values, which is x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. And that will give us, let's see, the values of 5 plus negative 11 divided by 2, and we have negative 7 plus 5 divided by 2. That will give us, let's see, 5 plus negative 11 is negative 6 divided by 2, and negative 7 plus 5 is negative 2 divided by 2. That will be negative 3 comma negative 1. So this, ladies and gentlemen, is your midpoint. That's step 3. Last but not least, we have step 4. This is your final step. Write the equation of the line. Now, what's great about geometry is that you learned a new formula that you didn't even learn in Algebra 1. And this is called the point-slope form of a line. And the point-slope form of a line is y minus y1 equals m times x minus x1. You use this if you're given a point and a slope. And in this case, we do have both. We have the slope of 4/3, and we have the slope, and we have the midpoint of negative 3, negative 1. So what I'm going to do is I'm going to use this information, and I'm going to go back to my equation and plug in 4/3 for my slope and negative 3, negative 1 for the point. So we get y minus a negative 1 is equal to the slope of 4/3 times x minus a negative 3. Now the signs change. So we get y plus 1 is equal to 4/3 times x plus 3. And you match that up to the answer choices. The answer is going to be choice 1 is the same thing. All right. That is the conclusion of this video. So, please visit my website at www.nysmathregionsprep.com for a lot more math content in geometry and other math courses. And please hit the subscribe button to help me out. And I hope that you learned a lot from this video, and I will see you soon.